Okay, now let's review the hypothesis testing three, which are three samples, the small samples, t-test, and gamma function. Um, so, so the reason why we do t-test is because sometimes if n is very small, when we are doing the leaf work, you divide it by a very small n, you will actually get a pretty large number, which is like not like not in the score table. So like for small samples, we can use the alternate, like we can use t-test to test if we want to reject or didn't reject the null hypothesis. So like one thing I want to mention here is that so for small samples, usually like we're talking about it is less than 30 because the central limit term says like bigger than 30 samples, the test will guarantee the same. However, like for t-test, even if the sample size is greater than 30, you can still use the t-test. Actually, if you look at the t-test, the t-table, there are like sample size greater than 30 or 40 or even 100. So just to remember about that. And today we're looking at an example from discussion 25, section 2, problem 1. So in a general population, heart rate are normally distributed with a mean of 72. And we samples 40 patients in ICU, and we had a mean of 95.3 and a standard deviation of 16.9. So we want to find if the heart rate of the ICU patient is unusual. So we want to use the t-test. I mean, we can also use the z-test because the sample is 40, but to review for the concept, let's use a t-test. So let's first set up our experiment. We want to have a null hypothesis and the alternative hypothesis. So our null hypothesis is the mean is equal to 72, and alternative hypothesis is the patient heartbeat is annual, so it's not equal to 72. So remember, it is not in this case the alternative hypothesis is not greater than 72. It's not equal to 72. So that means it is a two-study test instead of a one-study test. And then for calculating the t-test, we want to look at the degree of freedom. And t-statistics and two-sided for one-sided. So we know that this is a two-sided test. And what is the degree of freedom? Degree of freedom in this case is equal to the sample size minus 1. So sample size is 40, so degree of freedom is 39. And what is t-statistic? So t-statistic is basically calculating in the same manner as the z-statistic. So in this case, it's our measurement 95.3 minus 72, our mean, divided by the sample standard deviation, which is the given population standard deviation divided by the sample size, which is 40. So we get this is roughly 8.72. So with all this information, with the degree of freedom and two-sided test, we can like plug into a t-table or a t-calculator, and and we will get the result. And also we need alpha, the significant level, equal to 0.05. That's what the question is talking about. So we plug all these three information into the t-table, and we will get that the two-tailed t-test are plus minus 2.02. That's the result from table after plugging these checkmark values, which means that in order to reject the null hypothesis, we need to reject the null hypothesis. We need t is less than 2.02 or t is greater than 0.2, which means that but like our t statistic we calculate is roughly 8.72, which is greater than 2.02. This is a word. Which is greater than 2.02, so we can reject our null hypothesis. On a graph, the representation is that we have a distribution, and then we calculate the t statistic, which is 2.02 and negative 2.02. So this is our rejection zone. We can either like reject on the left hand side or the right hand side. But clearly our t statistic is on the right hand side, and it is in the rejection zone. So we can reject our null hypothesis and conclude that the ICU patients are in Euro. But again, like remember what I said, the sample size is 40. So we can either use the t-test or a z-test. So how about let's use a z-test again to calculate this problem. So if you want to calculate the z-test, we want to find the z-statistic. And we are given that the standard deviation of estimator for the standard deviation is the square root of n minus 1 divided by square root of n times s. So like you don't need to bother knowing about this. This is just like the information about estimator. How do we swap from the sample to the population? I guess. So this is like, I don't think this is covered in our discussion, but like just think about we are given 16.7 as the z statistic standard deviation. So we want to find the z statistic, which equal to 95.3, which is our measurement, minus the mean divided by the standard deviation. This gives us roughly 8.82. So again, if we want to reject the t hypothesis, we want to find a value corresponding to the significant value 0.05. So in this case, the z-value corresponding to the significant value 0.05 is z of 1, which is plus minus 1.96. So that means on a z scope, on the scope of z test will be 1.96 on both sides. And we just want to see if 8.82 lands on the rejection zone, and clearly it lands on the rejection zone. So we can draw the conclusion that we reject our null hypothesis. So as you can see, we can do this problem in two different manners. And that concludes my discussion for